Hello friends, good morning to all of you. Today we are going to solve the numericals based on the topic density of unit cell. In the previous video, we have discussed how to obtain the derivation for density of unit cell. In today's lecture, we will see that equation once again, the parameters involved into that equation, and then I will give you few tips and tricks regarding the problem solving, and then we will solve few problems based on it. So we start our today's topic numericals based on density of unit cell. So we start numericals based on density of unit cell. So in the previous video we got the equation for density of unit cell, and the equation is rho is equal to n into m upon a cube na. So this is that equation we obtained in the last lecture. Now today we'll see the significance of the terms again. So what are the terms here? Because once you understood the meaning of each and every term and their unit, then and then you can solve the problems very easily. So where this rho is called as density. So rho is called as a density of unit cell. So rho is called as a density of unit cell, and this is always in gram per centimeter cube. Then n, it is called as number of atoms or particles, number of atoms per unit cell. So n is called as a number of atom per unit cell. That means how many atoms are there in a particular unit cell. Let's say you have simple unit cell, you have only one atom. If you have BCC, you have two atoms, and if you have FCC, there are three atoms. Or this is also called as effective number of atoms per unit cell. Then you have m. M is called as a molar mass. So this m is called as a molar mass, and that is always in gram per mole. So by definition of molar mass, that molar mass is nothing but it is the mass of 1 mole of substance in gram. So therefore it is expressed in gram per mole. Okay, and then you have A as a age length. And this is always in centimeter. So remember, you must put your age length in centimeter. In problems, this age length may be given in any other unit. For example, in picometer or either in nanometer. So you must know that conversion factor to convert the picometer into the centimeter. And then about Na, which is also called as which is the Avogadro number. Na is called as a Avogadro number, and this number is nothing but that is 6.023 or 22 into 10 to the power 23. So this number. So once you understood about the significance of the terms in the particular formula, then we can solve easily any problem. In the board examination or either in the entrance examination, any parameter out of these 5 parameters they may ask in the examination. So let's say suppose they ask what type of unit cell it is. That means you have to calculate the value of n. So if your n is equal to 4, that means your unit cell is FCC type. Okay, or they may ask directly straightforward density of unit cell. So you must be able to solve any parameter out of these 5 parameters. So just take the screenshot, or also in the board examination the question may ask, write the formula for density of unit cell, and then give the significance of terms in the particular equation. So at that time you have to write this equation for 1 mark and whatever the parameters for 1 mark. So just take the screenshot. Okay, now we'll solve some numericals based on that. Before that, remember one physical conversion for the age length. In problem, most of times the age length that is given in picometer, and that time you have to convert that picometer into centimeter because your density is in gram per centimeter cube. So here centimeter is there, so therefore your age length must be in centimeter. Okay, so 1 picometer is equal to 10 to the power minus 12 meter, or either you can write 10 to the power minus 10 centimeter. So this is that important conversion factor that you must know while solving the problems. Means if the density is given in picometer, you have to convert it into centimeter. Means just multiply by the factor 10 to the power minus 10. So then solve for density. So we will take a few problems based on it. Okay, so I will write the first problem for the density of unit cell. Okay, so the first problem is problem number 1. So problem 1. So I will write the problem. Copper crystallizes into, so you write down copper crystallizes into FCC. Copper crystallizes into FCC lattice with age length 361 picometer. Calculate the density. Calculate the density of copper. So this is the problem. First read out carefully and then see what are the parameters given into the problem, and then so this is given to you. So what is given? So they have given the molar mass. So molar mass of copper, so that is given 63.5 gram per mole. So that is given. Okay, and one more thing they have given, that is Na is given. Na is Avogadro number. So what is that number? 6.023 into the 10 to the power 23. Okay, so this is the problem. So read it carefully and then solve. So we'll solve this solution for this particular problem. So in board examination they may ask this problem for 2 to 3 marks. So copper is the metal and that crystallizes in FCC. Means the unit cell of copper is of FCC type. That means if it is FCC type, that means the total number of atoms in the FCC unit cell is equal to 4. So that you must know, or you must remember that simple having 1, BCC having 2 and FCC having 4, and then you can solve this problem. Then second thing means the age length of that particular unit cell is given. So for age length, what letter we use? For age length we use A. Okay, so 361 picometer. So here you have the age length that is given in picometer. Okay, so this is the age length we use for age length So this is the edge length, okay, of that particular cube. So for edge length 361 picometer is there. So what I told you, convert this picometer into picometer into centimeter. So how many centimeter? 10 to the power minus 2 centimeter, okay. So or either you write 3.61 into 10 to the power minus 8 centimeter, okay. Then what is the third thing they have given? What they have given? They have also given the density, okay, molar mass. So for the molar mass, what we use? M, and that is already in gram per centimeter cube. So gram per mole, okay, gram per mole. And the next one they have given Na, and Na is 6.023 into 10 to the power 23, okay. So per mole, so this is in per mole, okay. And the last one, what they ask, calculate the density. So they ask for density of unit cell. So straightforward problem is there. So just write the formula and then solve the problems about the density. So here, so what is formula that you are using? Formula. So what is the formula? Density is equal to N into M upon A cube Na. So is equal to, just substitute the values in the particular problem. So N into M is molar mass, and that is given in 63.5. Sometimes remember this may given in kilogram. So you have to convert this kilogram into gram, okay. So N, value of N is 4. Value of N is 4, okay. And then A cube, so edge length in centimeter. So that is 3.61 into 10 to the power minus 8, and the cube of that into Avogadro number. So 6.023 into 10 to the power 23, okay. Now you have to solve this with the help of log table in board examination, okay. So just I will do some calculations directly here. So rho is equal to, now here see this 4 into 63.5 upon, now this one 3.61 cube into, so 10 to the power minus 8 cube means it becomes 10 to the power minus 24, okay. And 10 to the power minus 24, and this 10 to the power 23, that will become 10 to the power minus 1. So that comes over here, so that will become 10 to the power 1, okay. And then you have 6.023, so is equal to, so I will write here the cube of that one. So this one, this particular multiplication, that comes out to be 2540 upon, so this particular cube, that is 47.045 into 6.023, so is equal to 2540 upon 283.35, and that comes out to be 8.96 gram per centimeter cube. So this is what about the density of the given copper metal. So this is how you have to solve the problems. Remember, you have to solve this particular calculation with the help of log table only, okay. So just do the calculations properly, you will get the density. And remember, this must be in gram per cubic centimeter cube, gram per centimeter cube, okay. So just take the screenshot and then we will solve the next problem on the basis of density of unit cell. Okay, I think you are getting this particular problem very clearly. Okay, so put the proper things and care about your physical conversions, otherwise the problem will going to be wrong. Okay, so this is about the problem number 1. Now we will solve the next problem, that is problem number 2. Now the problem number 2 is again on the basis of this same formula, but here the different parameter that is asked to calculate. Okay, so just write down that problem number 2. Problem 2. So this is the problem number 2. Okay, so I will write down an element x. So instead of that element they are given as a x and its molar mass is given. So molar mass is equal to 60 gram per mole. So x element having molar mass 60 gram per mole has a density of, so density is given here. Okay, very interesting. So 6.23 gram per centimeter cube. Now what they ask, identify the type of cubic unit cell if the age length. So again age length is given here. Age length of unit cell is 4 into 10 to the power minus 8 centimeter. So here the age length directly given in centimeters, so no problem about conversion, that is picometer into centimeter. Okay, so this is the problem. So you have to solve this problem. So first of all write the data for this particular problem. Now what the problem is given, element x is there, molar mass is given. So directly I will write the molar mass, and for molar mass we use capital M. So what is the molar mass of that one? 60 gram per mole. Okay, so this is the first thing that is given. Then second thing, what they have given, the density of that particular element is given. So density is given means rho is given, and what is the density? 6.23 gram per centimeter cube. So that is the density that is given. Okay, and then third thing, what they ask, what is the type of cubic unit cell? So how do you identify the type of cubic unit cell? Once you get the number, means once you get the effective number of atoms or you get the number of atoms per unit cell, you can identify the unit cell. Means if n value comes out to be 4, that means it is FCC. So like that. So n that you have to find out here. So n that you have to find out. So that is question mark. So then one more thing is given, the age length is given. So age length A, and that is 4 into 10 to the power minus 8 centimeter. And the one more parameter that you require here is the NA, because NA is there in the formula. So NA they may give you in the question paper as a physical constant. So or also you must remember this one. So this is very important number in chemistry. That is Avogadro number 6.023 into 10 to the power 23. So this is very important per mole. Okay. So these are the things that are given, and then write the formula. Okay, write the formula for solving the problems. So what is the formula? Rho is equal to n into m upon a cube Na. So this is the formula. Okay, so by using this formula you have to solve the problems. Now in this formula, now today we have to calculate n here. Okay, in this particular problem, n that you have to calculate. So write n is equal to, so n is equal to what? Rho into a cube into na. Okay, and then yeah, upon m. So whatever is to be asked, that is on left hand side, and what is given, that is on the right hand side. Okay, and then just put the values here. Okay, so what is the value of rho here? So density, so that is already in gram, here in centimeter, so no bother about the conversion. Okay, so density is given 6.23 into a cube. So a cube is this one, so 4 into 10 to the power minus 8. Okay, and cube of that into Avogadro number, so 6.023 into 10 to the power 23 upon m. So what is the value of m? 60. So m value is 60. So this is what about things. Okay, now here next one. Now I will do here some calculations. So here 6.23 into, so 4 cube 64 into 6.023 into 10 to the power, so minus 24 and this one, so that is become minus 1. Okay, 10 to the power minus 1 upon 60, so is equal to, so whatever this multiplication, that comes out to be 2401 upon 49. Okay, 2401 upon 0.49 divided by 60, 600, because this 10 to the power minus 1, if you have minus 1, then here to the down it becomes 600. Okay, denominator it will become 600. So this calculation comes out to be n is equal to 4. Okay, so this 10 to the power minus 1, denominator it become 10 to the power 10 to the power 1, so 10 into 60 it becomes 600. Okay, so value of n is 4. So what is the meaning of that? What they ask in the problem? They ask about what is the nature of unit cell of that particular x element. So nature you can identify by the n value. So if n comes out to be 4, that means the unit cell is FCC, that is face centered cubic unit cell. So this is what about the problem, second problem based on density of unit cell. Now students, you have such type of number of problems given in the textbook, in the exercise. So do the practice of all other problems on the basis of density of unit cell. So today this is what about the formula, some tips and problems based on density of unit cell. Thank you.